So let us look at how animal cells respond to different osmotic solutions. So now, first thing is, why do we need to know that, how cells behave in different osmotic solutions? First, let's define what is osmosis. Osmosis is nothing but a movement of solvent from higher water potential to lower water potential. Now, this can be defined in another way also. So, from more water to less water. So, what is water potential basically? So, ability of a water to move from higher concentration to lower concentration. Now, the pure water has uh, highest water potential, and any solution that has some solute in it has actually less water potential than pure water. Now, by changing the solute concentration, we can make three different types of solutions, osmotic solution. That is hypertonic, hypotonic, isotonic. So the hypertonic means the solution has more solutes in it. Okay. So and when you place a cell, animal cell in a hypertonic solution, what happens basically the water moves from the higher water potential. That is now, since the water potential is low outside because it has more solute concentration, and the water is going to move from inside of the cell to outside of the cell. Okay, so this is how an animal cell behaves if you place an animal cell in hypertonic solution. Now, why does this happen? The reason is basically when you place solutes in a water, basically you are reducing the kinetic energy of water molecules, hence they are not going to move as good as pure water. In such cases, the water moves from higher water potential, that is now here inside of the cell, basically the water potential is high, and outside the cell water potential is low. That's why the net movement of water is from inside of the cell to outside of the cell. Now here, the animal cell, let's say if you keep animal cell inside a hypertonic solution, the water is going to go out, then the cell is going to shrink. Now, what happens if you keep water, if you keep cell in an isotonic solution? So, the isotonic, as the name itself indicates, the solution, outside solution, and the inside the cell, the water potential is same. Okay, in such cases, the net movement is zero, and the cell is not going to change its shape, or cell is going to remain same. Whereas in hypertonic solution, cell is going to shrink. Okay, by the way, these two, when I'm talking about shrinking, and this is applied to an animal cell. We are talking specifically about animal cell. Isotonic solution, nothing is going to happen. Whereas if you keep a cell in hypotonic solution, now what is the meaning of hypotonic solution? This means it has lower solute temper, which means basically it has high water potential. Now the water moves from higher water potential to lower water potential. That is, the water potential outside the cell is high compared to inside. In such cases, basically water moves from higher water potential to lower water potential. That is, from outside the cell to inside the cell. Now, what happens in such cases? Once the water start entering, cell might even burst also. Okay, now this is the reason why the IV fluids that medical practitioners use, they are most of the time, or maybe all the time, they are going to be isotonic. The reason is if you use hypotonic or hypertonic, it is going to cause damage to your cells. That is why the IV fluids, that is particularly saline, they use 0.9% saline, right? So this is isotonic. That is, if it has same water potential as inside the cell, in such cases, cell is not going to be damaged. This is the real life application of knowing isotonic solution. That is the reason why IV fluids are always isotonic. So now whatever I've explained so far is only basically applicable to animal cells. Now whatever the bacterial cell, so they are different from animal cell in one way. I mean, there are many differences, but one particular difference that I want to talk here is basically they have a cell wall. Because of the cell wall, when you place a bacterial cell in hypotonic solution, basically it is not going to burst. Okay, instead it is the plasma membrane which is present. It just might go away from a cell wall. Okay, and the same thing is going to happen even if you place a plant cell also in hypotonic solution. Whereas in hypertonic and isotonic solution, basically, yeah, so sorry, whatever I said so far is applicable to only hypertonic. Okay, so hypertonic is, so when you place a bacterial cell in hypertonic and plant cell, so what is going to happen here? So the solution going to come out, and it is going to shrink, and it is, oh, the plasma membrane might go away. Whereas if you place here in hypotonic solution, uh, the water is going to enter for both bacterial cell and plant cell. In such cases, it is going to exert a lot of pressure on a cell, but because they have a cell wall, both bacterial cell and plant cell, since they have a cell wall, they are not going to burst like a animal cell. So that is the difference between a plant and bacterial cell versus animal cells when you place them in a different osmotic solutions. So as I mentioned, one real-time application is basically isotonic solution. Okay, thank you.